grade what I can this weekend, and I'll get back to you Monday, and we'll talk about that more on Monday. How do you feel? I meant Tuesday. Sorry, I meant Tuesday. But how do you feel otherwise? You feel like you kind of knew what you were doing? Give me a 1 out of 10. Like 100%, 50%, 20%, whatever.
40%.
In your hands. Okay, so I got a decent idea of where some of us feel. But overall, we're looking like we're doing okay. And I could see your correct answers as you were going, so we're good. All right, so I'm going to ask you guys first to calculate. If you've already done this, then thank you. Calculate how old you are in microseconds. So I'm going to show you the process for that, but this is what dimensional analysis is. This is the topic for the rest of the day. So I call this part 1 because your brain needs to see this, your brain needs to practice this. And then part 2, we will do some more like the word problems related to this, more the advanced problems on Tuesday. But this is basically the math of chemistry, and we'll do this for the rest of the year. Later on, we call it stoichiometry, but right now we're calling it dimensional analysis. It's the same thing. So what we're going to do is we're going to process how do we think about conversion factors and utilize them in a mathematical problem-solving setting. So what do I mean by conversion factor? And this is what I was speaking of yesterday at the end of class. If I say 1 year, immediately you're thinking about something that's equivalent to that. What is it? 365 days. And I know you could easily think about like how many hours that is in a year, how many seconds that is in a year. You could probably do some math, but you could get there. But why do that if our process, the way we solve problems, will do it for us? We're basically going to take the easy way out. So let's, Grant, how old are you in years? 17. Okay, so 17 years. And you guys can do this for yourself, okay? If you're 17, I got you. But write down the process because I want you to see how this works, okay? So using dimensional analysis, which is a process of using units or unit cancellation and converting. So we're using units. We're describing units, but we're going to cancel them out as we go to totally convert 17 years to something totally different, which in this case is microseconds. Now, since I don't know how many seconds are in a year, I'm going to go with what I know. I know that, and I'm going to write this slightly different just because some people like it this way. It's called the fence post method. You draw like a little line all the way across, and you're going to set up conversion factors, things that are equivalent to each other, top and bottom. So if I know in 1 year there are 365 days, basically by putting a year on the numerator of this numerator denominator thing that's going all the way across, by putting one in the numerator and then one in the denominator, I'm allowed to cancel that unit out because I've effectively canceled it out by negating them from each other, numerator and denominator. So I could right now stop and go, okay, 17 times 365. You guys throw that in the calculator right now for me. $6,000 what? 205. So you are 6,205 days old, right? So that's helpful, but I'm still not to the final answer, which is microseconds. So I'm not going to stop and calculate at every step, but what you're basically saying is that this step I have converted years to days, okay? And the next step, what would be the next logical step for time for us? Hours, because you can easily do in your head, okay, I need to cancel which unit right now? Days, because days remains up here. I need to drag it down here. And when I drag days down here, or day, I know that I'm going to convert to my next logical step, which because we know time really well, we know that's hours. So which one gets the 1? 1 day. And how many hours are in a day? 24 hours in a day. Okay? I could then stop and calculate, but I'm not still to my final destination. But what I can see is every time I'm canceling one of the units out, because one's on top, one's on bottom. So the day cancels with the day. Now what unit do I need to cancel? Hours. So I'm going to put hours here. And what's the logical progression into the next unit of time? Minutes, because we generally know how many minutes are in an hour. So which of these gets a 1? 1 hour contains 60 minutes, okay? So again, you can see the cancellation occurring as hours cancels with the secondary hours listed below it. Okay, what now needs to cancel? Minutes. Okay, what's our logical time progression now? Seconds, okay? Because we just naturally know how many minutes and seconds correlate. So which one gets the 1? 1 minute and 60 seconds. Okay, are we to the final destination? No. Okay, so this is where King Henry comes in, okay? I'm going to write that up here. How did King Henry die? divide by drinking chocolate milk. Where's micro here?
All right.
All right, now that's milli, right? That's not micro. So it's dot, dot, micro, and then if I want to go further, dot, dot, nano, and there's pico after that. And on this side, there's dot, dot, mega. We don't use mega until unit 2, but it's there. Okay, so basically, I want you to tell me where second, the base unit of second exists on this number line. B, base, right? Everything that's a base unit that doesn't have a prefix exists at base. So what are some of those units one more time that we would call a base unit? Grams. Shout them out, let's go. Liters. Seconds. Say again?
The one for electricity is amperes or something?
Oh, amps, yeah. Amps, or amperes is how it is said. What else? Mole, and that's a unit of chemistry we'll use a lot later.
Meters.
Meters. What do you notice that's common about all these? They have no prefixes. Until I throw a prefix on it, it is called base unit. So since I'm talking about microsecond, I'm going to convert second to a microsecond by just, or I'm going to correlate them by figuring how many zeros are different between that base unit and where micro exists on the board here. So what I always ask everyone to do is pick the larger unit, second or microsecond. Second is like a ton bigger, right? So we're going to put a 1, do something black, put a 1 right under base. Okay, so my 1 is right under base. How many zeros does it take me to get to micro? 1, 2, 3. These dots count because they're placeholders. 6 zeros away. So that's how many microseconds are in a second. How big is that?
A million.
It's a million. A million microseconds are in a second. I ain't got time to write 6 zeros. I prefer scientific notation. So I'm going to write that here. What goes in the bottom?
Microsecond.
So who says seconds? Okay, why? It needs to cancel. Okay, because second needs to cancel. And microseconds are going to go on top. Who gets the 1? And why did we put, and how did I indicate that up here? I put a 1 under the base because it was the bigger unit, because I'm going to have one big unit and then a ton of tiny other units. So that's why that makes sense. I have 1 second, and how many microseconds are in a second? Or also known as 10 to the 1, 2, 3, 4, 5, 6. Yep, 10 to the 6. I will not waste my time writing 6 zeros up here because then it gets really long too. Okay, what cancels? And I didn't show the last ones, but what units have canceled? Minute here, yeah, and second here and here. What is the only unit that's not scratched out here? Microseconds. Okay, so we have effectively put our units here. We have all our numbers here. This whole process, when we mathematically calculate it, will convert 17 years to what that still 17 years is, but now noted as it is in microseconds. So in your calculator, we're going to multiply the entire numerator across. Okay, so what do we put in our calculator?
17.
17 times, whoa, hold up, we got to go all the way across. 17 times 365, because what you'll notice is I only cancel the unit, not the number. The number is important to show the conversion process. 17 times 365 times 24 times 60 times 60 times 10 caret 6. And oh my lord, let me get some scientific notation. Oh, change the mode on the calculator. Okay, I can do this. How do you guys do on your calculator?
It just showed up.
It just says, yours says it. Okay,
Oh, it's that big?
hold on, I know how to do this.
E means times 10 to the
Yes, E means exponent. E means times 10 to the whatever the exponent says. I am a smart human being. Hold on. This calculator, so my pre-cal teacher gave this to me in 10th or 11th grade whenever I took pre-cal, and I've had it ever since. I know how to do this. Oh, but my calculator died, so it reset all my formats. All right, so I'm going to take y'all's answer for that and write it up here, and that answer is start. 3, 6, 1, 2.
No, 1, 1, 2.
I love it when I try to get this to be like a chorus. It's 1, 1, 2. I'm gonna stop there for a second. Okay, times 10 to the 14. Can I get a thumbs up? We all just multiply. We got that. Okay. So So that's the big number that's representing the numerator. We would normally take this and divide it by the number in the denominator when you multiply the denominator numbers across. But these are all what? 1. So, okay, you got this in your head, right? Same answer, right? Dividing by 1 doesn't change it. So, what I now need to do is, my initial measurement was 17 years. How many sig figs here? 2 sig figs, right? This needs to be recorded to 2 sig figs. 5.4. Why did I drop, or why did I not put 3 6?
Because that's 3 sig figs.
Okay, that's 3 sig figs, and so why did I just put 3?
Because 6 rounds to 4.
6 rounds up to 3 up to 4. So that's 5.4 times 10 to the 14th microseconds, and that would be our final answer. You are that many microseconds years old. I don't even know what that number is. Nice. Okay. So that is called dimensional analysis. And the whole idea is that it shows how units relate to each other, and then as we cancel the units out, we've effectively converted one unit to another. Sometimes they're really easy. Sometimes I can say like, hey guys, I got 3 feet. How many inches is that?
36.
36. Sometimes they're one step. I made you do this many steps to see that you could do it because you know all the background information. What I'm going to start showing you is some familiar things like the metric system, King Henry, and I'm going to show you some unfamiliar things. So I can say, okay guys, the equivalency is 1 unicorn equals 4 rainbows. And if I tell you that is an equivalency, that is an equivalency that you can use like this. So if I tell you something is an equivalency, even if you don't know what it is, just go with the flow, cancel units, calculate, answer. Because some of these things might look unfamiliar to you, but you have a process. Okay, so this is called dimensional analysis, but it's also called factor label method in your textbook. And this is legit. I mean, like, I didn't make this one. This is legit. Okay. So I'm going to show you a couple with density first. Okay. This is notes. You will want to write down notes. Okay. Yes. Yay, absentee buddy, the first person. Yeah. Alright, so I saw a lot of y'all's reading, guys. Keep those out, and then I'll take questions on it at the end of class. Right down there. Okay, so I'm going to walk through these, and as soon as you're like, oh, the light bulb has gone off, you got to let me know. Because as soon as I get most of the class on the same page, we're going to start our homework. Because that will give us a chance to kind of practice what we're doing. All right, so when we're using density, what you'll notice is anything that has a fraction like this, okay, so that's 2.7 grams, and I know it's a slash, but truly that's a division symbol, right? That's 2.7 grams per centimeter cubed. Well, how many centimeters is this speaking of? If it's not written, what do you think? 1, right, that's for every 1 cube. For every 1 cube or cubic centimeter of whatever this is, aluminum, its mass is going to be 2.7. So that is a conversion factor. Density is always a conversion factor because it's fractional. There are some other things that we could write as conversion factors, but I can show you it like this. But we used that already. We used it as a fraction, which we wrote as 1 year, and we can say 365 days is underneath it, or we can write it as 365 days over 1 year. It doesn't matter which way we write it, but we have to have a purpose for writing it like this, where it's year over days, or a purpose for writing it days over year. So we have the power to flip a conversion factor whenever we want to because it's an equivalency. All right, so in the problem like this, we're starting off with a given, and this given piece of information usually has only 1 unit, so it's not like not a fraction like that density one is. And then the question is grams, right? So when you're looking at your question first, you're analyzing the pieces that are given. The given is given as 1 unit. The question is given to you as another unit, which is the one you want to convert to. And then either in the back of your mind or in your textbook or like here on the board, you actually have a conversion factor in front of you. So this is a conversion factor for this particular problem. So I'm going to start by writing out the given. All you got to write out is 40.0 centimeters cubed. And I'm going to try to use that fence post method, that little line thing, all like I just did. But you don't have to do it like this. You can do it like I did yesterday. I'll kind of flip back and forth. So we start with our 40. We know that's over nothing, so you can either put a 1 there or put nothing there. It's not that first lower box is not important. But what I want to do is take this conversion factor, and I want to see the similarity between my given and the conversion factor. What unit is there in common? Shout it out. Let's go.
Centimeters cubed.
Centimeters cubed. And I want to cancel the centimeters cubed out here so I can convert to grams. So if I want to cancel centimeters cubed out, or cancel it out totally, I need to take this. Do I need to flip it when I write it here, or keep it the same?
Keep it the same.
Keep it the same because it's written perfectly. I have the 1 centimeter cubed on the bottom already. I have the 2.7 grams on top already. And then what unit is on top and bottom? Centimeters cubed. Centimeters cubed. So I've canceled those two units out because they are top and bottom to each other. What unit remains?
Grams.
Grams. Have I met my final destination? Boom. I just need to calculate now. That's a one-stepper. So take your 40 and do what? Multiply by 2.7. What do you get?
108.
108. And what unit still remains? Grams. And I didn't divide by anything because there's a 1 down here. If there were another number, we would need to then divide. But there's a 1. How many sig figs are in my initial measurement? 3 sig figs. This is a kind of like a constant, and constants, they're not truly measurements. They're a combination of measurements, but we call them a constant. So disregard this for sig figs. You're generally sticking with the initial measurement taken, and then check out how many sig figs I have here. 3. I'm happy. I'm good. That's my answer. Give me a thumbs up if that one so far made sense. Okay, I'm making some eye contact with some folks. I want to see where we are. All right, so we're going to use the same process, but we're going to solve this one. We still have that conversion factor of 2.7 grams per centimeter cubed, but what are we starting with for the given in this case?
2 grams.
40 grams. I'm going to solve it right here. Okay, we have our 40 grams. We're going to write our little division symbol and so forth like this. And knowing I have 40 grams, and it's saying how much space, what do you think it's really asking for here?
Volume.
Yeah, truly it's asking for volume, which is in what unit? In this case, it's going to be in centimeters cubed. It could be in milliliters, it could be in liters. There's a lot of volume units out there, but we're going to stick with centimeters cubed. So the real question is, how many centimeters cubed is equivalent to 40 grams of aluminum? Now, we have this conversion factor. It's written right here. Can I just take the 2.7 grams by 1 centimeter cubed and plop it right here? No, why?
They won't cancel.
Because then grams will be next to each other and they won't cancel. So I have to take this, and when I flip it, the gram stays with its 2.7 and the 1 stays with its 1 centimeter cubed. We have to keep those numbers where they are, or with the unit they're with, or we're flipping the whole thing. So it goes up top. 1 centimeter cubed, and what goes on bottom? I hear somebody shyly saying the right answer. 2.7 grams. Now what happens to grams? They cancel because one's on top and one's on bottom. What unit remains?
Centimeters cubed.
Centimeters cubed. So I know the final answer is going to only have centimeters cubed in its final answer form, but what do I mathematically need to do now?
Divide.
Yeah, I have to divide, which is 40 times 1. Okay, we got that. But now we're going to divide by what's in the denominator, which is only a 2.7, so there's not much to do there other than just divide. And what you get?
14.8.
14.81, I'm going to write this out here all the way, 8148 centimeters cubed. So I can't take this entire number because that would be too many sig figs. How many sig figs should I have?
3.
Why 3?
That's the original.
Because I'm starting off with 3 sig figs, great. And this needs to be rounded to what? How many, so what am I going to be writing? 14.8.
14.
That 1 does not influence the 8 to go up, so I'm writing 14.8 centimeters cubed. You good?
Yeah, we cancel.
Yep, they cancel out, and so the only unit remaining is centimeters cubed. Alright, so those are simple because they're single step ones. The more examples I do, the clearer it gets and the better you get at it. So I'm going to throw up some other ones, and then I'm going to stop and kind of let you guys work for a while, and I'll take some questions from other folks who have some issues. Alright, so you see a list of conversion factors here. Again, tell me how you know these are conversion factors. The fraction one, right? I'm telling you it's a conversion factor of 1. And 2, you know that they are conversion factors because they are 2 units. I won't say it like that, because they're a fraction. Put it like that. So they have the kilojoules per mole. They have grams per milliliter. They have grams per mole. They have joules per calorie. They have moles per mole is a unit in chemistry that means a big number, and this is that big number, and that's telling you there's a number of molecules associated with that. It's just same. This actually is the same thing as me saying 1 dozen is equal to 12. So 1 mole is equal to big number, but of particles, molecules. So I'm just telling you all these random ones, right? But I want you to help piece this puzzle together. So my goal for you is to convert 40 grams to moles. So what your job first is do you see a conversion factor with grams and moles in it?
Yes.
Yes. So how many steps is it going to take us? 1, because we only need that 1 conversion factor. So start your process first. Talk to the person next to you because they may need like a little guidance too.
You need, well,
Two.
it's like 40,
It's like 18.02.
18.02 grams. So you're going to put the grams on the bottom so they cancel out from here. 40 grams. So then it's 18.02 grams.
So 1 gram will be on the bottom, 18.02.
18.02 grams.
How do you label like
And then you would just multiply across
the swirl of moles?
40.02.
M-O-L-E-S is actually what it is.
Choose many.
So what you guys write on the bottom?
18.02.
So you guys found the single unit conversion that has grams and moles in it. You saw the 18.02 grams, and you saw the grams here, and you said, okay, grams have to cancel, so you put 18.02 grams on the bottom. And then what went on top? How many?
What?
1, because everything that doesn't have a number in front, like calorie, milliliter, mole, everything there will have a 1 associated with it. Okay, we have successfully made it to moles, and we will cancel what unit? Grams, and then mathematically 40, so what you're doing in your calculator is 40 times 1, and then you'll divide by 18.02. And what we got? Say again? 720?
Yeah.
I like to double check you guys, only because of like butterfingers. I got 2. Okay, cool. 2.2. I'm gonna go the whole shebang first. Okay, 2.21976, and that would be what unit? Moles. Okay, so that's what your calculator says. But what you're starting to get at is you're going back and referencing the initial sig fig, and you're saying this has how many? 3 sig figs. So this should end up with 3 sig figs, which is what?
2.22.
2.22. Good, because I need the 2.2. I need that 1, but I can't have the 1 because there's a 9 after it, and the 9 does what? Rounds it up. 2.22 moles. And let's look at this. I mean, that makes sense. It makes so much sense. If 1 mole weighs about 18 grams, and I got 40 grams over here, what's 18 plus 18? 36. So I already know I should have 2 times the amount, so I should have 2 moles, but because I have more than 36 grams here, it makes sense that I have a little more than that. So it does make sense mathematically as well. What's that? Yes. I'm going to scroll up a whole bunch of it. Okay, so you're going to do the next one, but I want you to talk to me first before you move on to the calculations. So do you guys see milliliters and molecules, right? So we're going from milliliters to molecules. Let's keep that in mind because I got to scroll up. So milliliters and molecules, do you see anything with milliliters and molecules in it together? No, so you know this can't be one step because I can't just do one and done. So I'm starting with milliliters, right? Which of these has milliliters in it? Density and, is that it? Oh yeah, that's it, okay. So I have to, guess what? Use what first? Yeah, so if I have milliliters as my given, the only conversion here I have with milliliters in is this, so this is going to be my first conversion factor. Because I have to use the milliliters to cancel milliliters. And then what unit will be on top of that point? Grams, because that's the other unit. Remember, I was going to molecules, right? Right? Okay, so I've got grams. Do you see anything with grams and molecules?
Yeah.
Grams and molecules. Mole and molecule are 2 different things, actually. Anything? No, I don't. So I have to get something with grams, but I can't straight get a molecule, so I'm putting the pieces together. But I'm hearing you guys say, I have to use molar mass, right? Because nothing else has grams in it. So this is going to be my conversion factor number 2. So I made it from milliliters to grams. I made it from grams down to moles, giving to molecules. Austin?
We don't need to memorize all these conversion factors.
No. Eventually you'll learn how to do them yourself, like maybe in 5 or 6 weeks. Okay. So right now I'm giving them to you. Because like all you do on this one, the molar mass, all you do is look at the periodic table, add up the masses of the elements. For this one, it's given on a reference table. This one you'll use so much you will have it burned in your brain. So, okay. So we went from milliliters to grams, grams to moles, and now we're going to go moles to, so I have to use which one? The last one. That's called Avogadro's constant. Not avocado, Avogadro. Okay. So I think I'm going to write that, I'm going to write it, I need those, you guys need those conversion factors, so I'm going to write it here on the board, okay? So what am I starting with? Oh, sorry. What am I starting with? 80.4 milliliters, okay? 80.4 milliliters. 80.4 milliliters. All right, so 80.4 milliliters. Make your little line. What goes on the bottom? 1 milliliter. And so we're using the 1 because there's no number with it, so we're assuming it's a 1. What goes on top?
0.9994 grams.
Grams. So why am I putting milliliters on the bottom? Everybody.
To cancel out.
To cancel out this milliliter here, cancel that milliliter out there. Now I'm in grams. What goes on the bottom of the next one?
Grams.
Grams, so I have to cancel it. And you guys already told me what the next conversion factor was. That molar mass one.
Oh, 18.
So what goes with the gram?
18.02.
18.02, because that's what this conversion factor right here says. And what goes on top?
1 mole.
1 mole, because it has a mole there, but it doesn't have a number source, so it's a 1. So this unit leads me to tell me what's on the bottom. The gram led me to tell me what was on the bottom. What this one's going to lead me and tell me that it's on the bottom. So mole goes down here, and what goes on top? That big number of molecules, right? So 6.022 times 10 to the 23rd molecules is equivalent to how many moles? 1 mole, because that's what it says up there. So these are conversion factors, conversion factors, conversion factors. And then we cancel, cancel, cancel. 1 second, okay? So mole cancels here. What's the only unit remaining? Molecules, which is what the question asked us to do. Molecules was the only unit that didn't get canceled. So, same story as last time. What did I mathematically have to do? Multiply across on the top. So, let's do that, guys. Anybody? Something like this times 10 to the 25th. Okay, so I was looking for that. So I stopped at this. Oh, I put 2. So my chemistry teacher in 10th grade or whatever taught me the 022, and I can't stop it. It's like a tick. I just have to keep saying 022, even though theirs is 2. So you might see that, and that's what my answers on here on from yours. Let's stick with what you got there. So you guys said 8.3. You just go back and erase that too. Is it basically the same? 4, 8, 3, 7, 1, 8. Is that what you guys said? Sorry, 7, 5. Okay, we got the numerator. It's good. It's so good. We got way too many sig figs. We're good. Let's go ahead and move on. Numerator now needs to be divided by the denominator. 1 times 18.02 times 1. I got this. That's 18.02. Divide.
2.684337.
2.68. What?
433.
Okay, stop there. Anything else? We're good? Or no, times 10 to the what?
24.
Okay. Okay, so we have made it to the number of molecules in 84 or 80.4 milliliters. This though is still not my final. And what's the final?
2.68
Times.
10 to the 24.
Because you still have to include the scale of the number. So the final answer is rounded to how many sig figs?
3.
3, because this up here started you off with 366, so it would be 2.68 times 10 to the 24th. Okay, yes.
Why did you put 10 to the 24th instead of 10 to the 24th?
Because when you divided that, it should have dropped down 1 0. Your calculator does it, so you don't have to think about it. Yeah.
The 4.8, it goes all in the calculator. I didn't know when to cut it off.
So generally, I don't write this number down because the numerator is going to be needs to be divided by the denominator, right? So I'm showing you that so for your purposes of like making sure you get your numerator, and then in your calculator, go and get your denominator, grab the number that you got from the numerator, divide by the number you just got from the denominator, and then when you divide, that will be your final answer. Because nobody wants to write out huge, like, 20-digit long number. Just grab it from your calculator. You guys can like scroll up in your calculator, right?
Yeah, and press enter.
And press enter and grab it. Okay. But if you're going to do that, keep a couple, especially, I just kind of go back to my initial zip thing and say, up through there, I'll try to double it to record enough so I don't have rounding error. Let's get some more like questions you might have just about little details here. Okay, we get a second thought. Give me a thumbs up, or like, I'm still not there, or like, oh my god, what the heck are we doing? Okay, you gotta be honest with me, because I will, I got lots and lots of examples, but I'm gonna get you to the part where you can do something a little bit easier first, okay? So I'm gonna try to get everybody to the thumbs up part. You've seen this before, yeah?
Yeah.
Wow, okay. We're gonna use this a little bit more. I started you off with something to basically show you that you don't have to know what all the units actually are. As long as you can cancel them, we're all hunky-dory here. You can do dimension analysis even with something you don't know what it is. But this is very familiar to you, so this should be actually simpler because you have a grasp of what the heck these mean. So we're going to utilize those now, okay? So this I printed on your student notes. So the stuff we were working on yesterday was the statistics is on one side. The other side has dimensional analysis practice. So I'm going to probably cherry pick like 2 or 3 from each sample, each type of problem, so that we get the hang of that style of problem, and then I will set you to do some homework. I'll set you to do some homework, and then I'll answer some more questions for some folks. All right, so we're on number 1. Where am I? I just lost the marker. It's okay. So notice that I'm starting you off with something pretty easy. We're going from what unit to what unit? Milligrams to grams. So on the top of your paper right now, because you will forget it, write down how King Henry died. I'm going to do it over here on the board so I can have all my space. Write down how King Henry died all the way out. All right, and everybody go to the milli and point milli on your paper, and then point to where gram is on your paper. My hope is that you're pointing at the M and the B. Okay, B is for base, and base is anything that does not have a prefix like gram. So we're going to start off first, and then we're going to go through how to use this number line thing. I have to start off by writing what? What's the given? 3,500.0 milligrams. How many stick figures are in that? 5. That's a pretty good measurement, right? Whoever had this scale had a really good scale. So before I was giving you the conversion factors on the board, right? I was like, these are the conversion factors, use them. Now I'm giving them to here. You just have to learn how to use this a little bit better. So we know that we have to convert and get rid of what unit? Milligrams. So where's that going?
The bottom.
The bottom. And we know we are converting to what?
Grams.
So it's going to go on
Top.
top. So your thought process is write your units out. So I'm just going to put like unit skeleton. So you understand that we're kind of just making a skeleton, put our units on top of it. And then 2, you're going to go to the metric number line, and you're going to find the conversion factor yourself. So what you do is you look for whichever one is biggest, and you put a 1 with it. Who's bigger, gram or milli?
Grams.
Gram. And that's what I was just doing earlier. Since this is gram, I'm going to put a 1 on the bigger unit. And we're going to put zeros until we meet the next unit. You'll do this for the first couple, then you'll get the hang of it. So I'm gonna put 0 at the deci, 0 at the centi, 0 at the milli. Guess how many milligrams are in a gram? 1,000. So you're basically saying 1 gram is equal to 1,000 milligrams. That's what you're saying when you recognize base is gram and milli is 3 zeros away. So that is your conversion factor. How do we write that up there?
The same way.
1 gram is equal to
1,000.
1,000 milligrams. Now cancel your milligrams. And then math. What do I have to do now?
Divide 3,500 by.
Okay. So if you need your calculator, use your calculator. But what you'll say is hopefully 3.5.
Yes.
That's what your calculator will say, right?
Yes.
But then you say, calculator, because it doesn't do 6 things for you. What do I need here?
3 more zeros.
3 more zeros. 1, 2, no, is it 3?
Yeah.
2, 3. Yeah, okay, so we've got 6, we have our decimal present, start from the Pacific. 1, 2 was not enough, because you guys told me to begin with there are 5 sig figs here. I need 5 more here. I need 5 total here. And adding gram on the end allows us to show that we've totally made it to the final destination of grams. A lot of your test questions are going to be similar to ones that I'm doing on the board right now, okay? So I'll give you some simple, 1 step, 2 step, 3 step, and then some word problems that relates to this. This was the part of the test, the free response part of the test that most people feel like they struggle with, which is why I'm trying to go a little slow on some of these first, okay? All right, so we made it. We're good. Moving on, using this metric system. Let's do number 3. What is that?
The micro.
Micrometer. Okay, do this with the person next to you. I would not be right on that little bitty piece of paper. Some paper, I will laugh using the note paper. You don't know if you're writing
Okay, so
You know how to do it, right? Like the micro?
well, the micro is 2 less than milli.
Yeah.
So that's 3 actually.
Yeah, so you'd add 3 or you would meters. You would move the decimal over 3 to the left, so it'd be 84.345. So 1 millimeter.
I was like, there's a lot of numbers.
Because we're moving to the left, not the right.
Yeah, so it would be 84.3456. And then in terms of how many seconds we're at the beginning, 1, 2, 3, 4, 5, 6, and just make it the same. Yeah. The answer is 84. Then we got 3.3456.
That's it.
Yeah.
I got the answer. Can you candy?
I don't have candy.
Can you invest in some candy?
I'll invest in you.
Let's go. I drink peanut butter. You don't have to write it.
65.
Yeah.
Start with 5.
Okay.
It's not over there. It's not over there. We're going to meet
So, for any meters to seconds. Okay, so first we write the meter.
Okay. I'm confused.
Meters to seconds.
Yeah.
All right, pause your conversations in 5, 4, 3, 2, 1. Okay, I'm sure we made it to the part where we were like, okay, got it written down as a given, and I see I have to cancel micro, so I put it on the bottom, and then meter is going to go on top. So who made it this far? At least this far. Okay. And then you said, I don't know this conversion factor off the top of my head. Go to the King Henry thing, and then what did you do? Set it up for yourself. Where'd you put the Y?
Base.
And why was it on the base?
This is just a meter.
Because it's meter, and it's the
Bigger.
bigger unit. The bigger unit is the 1, because inside that big unit, you're going to have a lot of little units. So you have 1 meter, and it contains how many micrometers? 1 meter contains how many micrometers?
1 million.
1 million, also known as 10 to the 6. So we put the 1 under base because that's our meter, and then we put zeros everywhere to get to the micro, and that allowed us to say 1 meter contains a million or 10 to the 6 micrometers. Yeah.
If it would have been millimeters, would you write MM?
Mm-hmm. Yeah, so it would be mm if it was millimeters. So micrometer or micrometer is how it's actually said. You'll take your canceling of units there, and then you'll take your number times by 1, divide by 10 to the 6. Should be 8.4346 times 10 to the, say again? I want scientific notation. Nope. Because when you divide by something with a large exponent, it's going to get a lot smaller. Yeah. Sorry, I gave my paper. Oh, where's the 3? Thanks for calling me out, because dyslexia hurts us at the worst times. Or just omission occasionally. I say I do. I constantly flip numbers, so I'm sorry if I do that. And there's a 5 over here. I've self-diagnosed myself. 4, 3, 4, 5, 6. Okay, so 10 to the what?
Fifth.
What? Not -6. Did you guys put this in your calculator?
Yeah, we get a decimal.
You get a decimal. Okay, so convert that decimal to scientific notation.
-3.
No.
-2? -2. So if you got 0.0843456, I want you to be comfortable with it that way and scientific notation. I'm going back and forth. So this basically was like, I artificially put the decimal behind the 8, which means I had to move it back 2 spaces. Yeah. So this is what you get in your calculator when you do this number times 1 divided by 10 to the 6. Okay? So when you do this number times 1 in your calculator divided by 10 to the 6, you get this up here. And I want you to be comfortable with switching back and forth between these two. So you artificially put the decimal, because in scientific notation your front number has to be between 1 and 10. I'm artificially putting it right here. But that means I have to move it technically back 2 spaces, which is why it's a -2. Okay? All right, we're going to number 5.
Let's do that.
So this is familiar unit stuff. And I want you to see how I'm starting you off with seconds on the denominator for both, okay? So you're writing out 88 meters and then per second. That's our starting point. But as we're converting, what's the only thing changing?
Centimeters.
Centimeters. The seconds is not changing, so I'm not going to touch seconds, because if it stays there, it stays in the denominator, which means it's going to look like that at the end. Don't touch the seconds. So I'm just converting meters to centimeters. So how do I write that up here?
Why don't you flip it?
Well, that's what I want you to tell me how to write it. So when you say flip it, just tell me how to write it.
Oh, so put the centimeter on the bottom.
The centimeter, it wouldn't cancel with the meter, right? So what do you want on the bottom? I'm going to just get the units for a second. So the skeleton, so meter goes on the bottom, and what goes on top? Centimeter. So you want the meters to cancel, right? Because you want centimeters instead.
Yes.
Okay? Now you go to the number line, you say meter to centimeter. What's the conversion? Where's meter here?
It's a
Base, okay. Where's centi? 2 away. So how many centimeters are in a meter? 100. So 1 meter has 100 centimeters in it. Math. What do you got to do? Oh, sorry. What cancels? What cancels?
Meters.
Meters cancels. What stays?
Meters.
Per second. Centimeters never canceled. Neither did seconds. So they're staying with us. Centimeters per second is how it's going to be recorded. And then you tell me the answer here? 8,800. How many sig digs in our initial? 2. How many here? 2. Final answer? As is. Somebody, I think, just knocked on my door. I'm just gonna hold off on that.
What a
Balance the door. I love my old students occasionally. Sometimes. I just ran. I'm gonna do this. Don't worry about it. Okay, so I'm gonna ask you guys to start 6. Start 6. I want you to think about how you would approach one of these units at a time. what's the first thing you guys already noticed about this one? There's two things happening, right?
Yeah.
It's a little bit more than the last one. Just take it easy. Go with the numerator first. Okay, what is the numerator doing? Grams is changing to what? Kilograms, okay? So I want to do that first. I want to convert grams to kilograms. So let's just ignore this milliliter for a second. Where do I put grams on the next part? Bottom. What do I put on top? Kilogram. And then you're going to say, okay, I know how to do this. What do I do over here? Where do I put the 1?
Under kilograms.
Under K for kilogram. Why?
Because it's bigger.
Because it's the bigger unit. So 1 big old kilogram has
1,000.
0, 0. Why am I stopping here?
Because that's the weight of.
This is where grams lives in the base unit, okay? And that means that in 1 kilogram I have what?
1,000 grams.
1,000 grams. You have to say that out loud to yourself because you'll forget, like, where do I put the 1? Or what do I do with this? So you need to use that number line a lot. Okay, successfully done, guys. Our gram and gram can cancel. Ignore this kilogram. It's staying there. Don't touch this. Go back to the beginning. Milliliter. I don't want that anymore. What does it want instead? Liter. The liter needs to be where in the final answer?
On the bottom.
On the bottom. Okay, so I want milliliter to cancel. So I know it's kind of transversing this, but it's okay. I can cancel something from here to here. It doesn't matter. So I can put milliliter where to cancel it? On the top of the next fraction. Because they're counter to each other, so they can cancel that way. And what did you say you wanted on the bottom? Liter. Okay, do the number line. Oh no, who's bigger?
Liter.
Liter. And the liter is under where? Base. Okay, so 1 liter contains
1,000.
1,000 milliliters. 1 liter contains 1,000 milliliters. What unit has canceled?
Milliliters.
And it's okay, you're canceling from here all the way over here, but as long as it's on top and bottom, it will cancel. What unit remains?
Kilograms and liters.
Kilograms and liters. Is that a highlighter? I'm not sure. Yeah, okay. Kilograms and liters are the only 2 units left. So, I don't even have to do the math. Look at it. Do you see the 1,000 and the 1,000?
They cancel out too.
Yeah. So sometimes you just have to double check, and the math actually became easy because I could see the 1,000 and 1,000 are going to wipe each other out. So what's the final answer?
4.5
4.52 kilograms per liter.
I guess that makes sense.
It does, because
Yeah, it makes
they were
sense.
both 1,000 and different from each other. Okay. So, how are we feeling? Give me the yay, nay, oh my god.
That's more.
Yay, nay, oh my god. Okay. Alright, so I appreciate the survey. I'm going to keep going here, okay? So I'm going to do it, and I'm trying to do more until you get really comfortable. This one we don't need to do, because this is exactly like the other one. This is an option for you. Like, if you get tired, you're like, I'm going to stop at the base. Instead of going from, like, kilo to micro, so if you're like, I'm going to stop at the base, and that's 1,000, and then we do another, million. So you could do, like, how many, you guys just tell me this, if you can do this, you can do any of these. How many micrograms are in a kilogram? How many micrograms are in a kilogram? 10 to 9. So that's
I think it's really.
a billion of sorts, right? So those are 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 kilogram is equal to 10 to the 9 micrograms. So you can get past base. This is for the people who struggle. You guys are okay so far. Let me pause on this one for a second. Let's go to problem set. Okay, if you have your computer nearby, I'm gonna pull it up too. I'm gonna let you guys work for a little bit on your problem set 3B, and then I'll go back and I'll do some of these. Okay. So here's what problem set 3B looks like. If you have a computer where you can share, that's fine. Oh, yeah, just drop it right there. We're gonna get back to you in a second. Oh, that's reading guides. If you feel okay. Do you feel okay? Like with this? right now?
Yeah.
Okay. Just let me show you what you're going to do first, okay? So I want you guys, this is problem set 3B, it's underneath problem set 3A, where your packet is, or on the itself. I want you guys to go to the prefix conversion one, and I want you guys to maybe 3 or 4, right now 3 or 4, and then I'll do the more complex ones, and we'll do 3 or 4, and then we'll move on where we need to, okay? So we don't have to do this whole problem set. I am happy, this is a beast of a problem set, but I give you enough time, so if I assign only half, you still have more to do for practice if you want, okay? Take 10. 3, not even 10. Take 5.
I'm doing 3B.
3B, yep. So if I can make this bigger for you guys can start up here. It's right smack in front of you, so. You will eventually be turning this in. So the point of I don't take up if the work, if your homework doesn't also work with it, I can give you the answers and you know if you got it right or wrong. The homework has worked with it, which is basically from here on out. I need to check some of that for accuracy and give you some credit and give you some help where you're messing up. So show your work. If you don't show your work, you don't get any credit. In the first section, 1 through 9, I want you guys to do 3 or 4 of these. Pick your poison. Do 3 or 4 of those.
Only 3 or 4?
Only 3 or 4. If you feel good with that, we are moving on. If not, you got the basic concepts. Not reading that. You got it, Evan? If you're looking at the concept, the very bottom of the concept has all the answers. You can check yourself as you go. I do that so you can give yourselves a pat from the back. You know?
Yeah.
Yeah. I think the last time they didn't have that. The last time it was just like this time you show works.
Remember in Jesus'
Keep going for another 2 minutes here. 3 to 4. Alright, if you're in the middle of a question, finish that once, and then I'm going to move on to the next section, and then we'll kind of work together on those. No, I a lot of times will, because it's simpler, it's convenient. Okay. Because if it's 8,000, does it have, how many sick days should it have? 2, and you have to send your vacation. 8,000. Oh, sorry. Well, that matters. All right. So look back up here. I'm going to give you some more. I'm going to give you 2 sample questions. I'm going to come back to help some of those who need some help here. So this is a squared or cubed unit type, and when the unit is squared or cubed, you have to do something slightly different with your conversion factor. You basically just cube or square your conversion factor. That's the only difference here, but I want to show you a couple. Okay. So this is on the lecture practice. Do your sample, you're writing your example down, write your little, fence post thing, and then your conversion factors, you're still going to be pulling from the metric system because you'll notice that's the metric system, cubic system here. So write 800.4 meters cubed. This is a sample question. If you want to label this squared or cube units type, this is just a different style. It's very similar though. So we're going from meters cubed to centimeters cubed, right? That's just basically us saying we're going from meters to centimeters, except we're dealing with volume units, so we're going to cube our overall numbers at the end. So just ignore the cube for a moment. I know I want to cancel out what unit here?
Meters.
Meter. So I'm going to put it where?
On the bottom.
On the bottom of this next fraction. I know that when I cancel the meter, I want to convert it to what?
Centimeters.
To centimeters. So I'm going to put centimeters right here. Just take a look at the meter and centimeter over here and tell me what the conversion is. Well, who gets the 1 first?
The base.
The base, which is the
Meter.
meter. And where's the centi?
100 away.
2 spots away. I thought I heard 1,000, but it's not 1,000, it's
100.
it's 100. Okay. So 1 meter is equal to 100 centimeters. Okay? So we're going to write that over here. 1 meter is equal to 100 centimeters. So we have to do one little trick here at the end. Because of this cubed thing right here, it basically means that the meter is cubed. This value here already represents the cube value that it is, but this doesn't, so we just put this here. So what we have to do is we have to cube everything that we just wrote and utilize that in the mathematical calculation. So basically, do the same thing with your units by doing your skeleton, and then you're going to adjust to be cubed or squared or whatever it may be, and we're going to use that in our calculation. But before I do that, let's cancel units like we have been. What's canceling?
Meters.
Meters
Cubed.
cubed, and here, meters cubed. We're going to end up putting in our calculator what? 800.4 times what? 100 cubed. Okay? Because what's 1 cubed? 1, so I'm not even going to worry about dividing by 1. So in your calculator, you put in this, and you get what?
80,400,000.
Can you give that to me in scientific notation?
No.
It should be yes.
That's right. Oh my god.
I'm thinking this is it.
What's the button calculator for that? So we can do it?
It's, you have to change the mode. Hit mode and go to scientific. Is this the 8th power? I did this in my head. Let me just make sure. Thank you. Aaron, you say yes? Okay, thank you. So this is not our final answer. What are I supposed to add?
The unit.
The unit, which is
Centimeters cubed.
centimeters cubed.
Which, you cube your answer and still leave the measurement in cube.
Because the measurement itself needs to be represented appropriately. Yep. So the only thing that's different here was we wrote our little system up, right? We put our little line. We ignored the cube for the moment just to get our bearings, and we put down meter and centimeter. We went to the number line. We said meter centimeter relationship is 100 centimeters in 1 meter. We put 1 and 100, and then we said, okay, this cube's got to be taken care of, and that cube will be applied to everything in our conversion factor. So the 100 and the unit, the 1 and the unit. We canceled our units, and then we multiplied across, including the 100 cubed. Let's do another one. Yeah, I guess we're going to do number 2 because I don't have any more after this. Number 2. signs of notation.
8.846 times 10 to the third.
Times 10 to the negative fifth.
The parentheses in your calculator when you divide. Alright, who got a positive exponent when they did their signs of notation? Okay, fantastic. Who got a negative exponent when they did their signs of notation? Okay, so you're dividing by a large number here, right? So how many, who's the larger unit, kilogram or meter? I mean, kilometer or meter? Or kilometer, not kilometer, sounds weird. Kilometer. Alright, so kilometer is 1, and then there's 1,000, so 1, 2, 3, 3 spaces over 1,000 meters in a kilometer. And then what did you have to do on top of that conversion? Square, 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 square. And then you canceled your meters squared. And then you have, I did this blind, that's for you. So the meters squared cancels. The kilometers squared remains. This is kilometer squared. And when you're throwing this in the calculator, though, and I'm guessing you guys are doing like 88.46, and you're just saying divide by, did you say 1,000?
1,000.
1,000. And then sometimes if you don't put parentheses around the 1,000 squared, it sometimes squares your whole answer at the end. So you just need to be aware of that. Some calculators are different. But when you put in your calculator, 88.46 divided by parentheses, 1,000 squared, parentheses, it should give you this, 8.846. How many sig figs are in this first number, by the way? 4 sig figs. So when you get 8.846 times 10 to the negative fifth, how many sig figs are here? 4 as well. So that's the only thing different with the squared and cubed units. All right, I'm going to release homework back to you. On the secondary set, and I'm going to keep coming around for extra help, you guys are going to, I don't know why I froze that. You guys are going to do, wait for it.
So when you said first half of the problem set, is that like up to the table?
Close, but let me show you a little more. And homework, there it is. Okay, so we've kind of gotten 3 to 4 done here. I want you guys to do 5 here. There are 10. Choose half of them. Some of them are the cube things. Some of them are those multi-units where you have a different unit on top and bottom, and I did one of those maybe 3 or 4 examples ago. So, when you get, that's only 9, up to, or not even 9, that's like 8 problems, right? You guys should start pieces of this, okay? But what I want you to do are do the ones you feel comfortable with. I'll see how far you get, which is why I'm saying half the problem set this weekend, or now. You still got 10 minutes right now. And then I'm going to go over some of the more wordy problems, which are like the lower half of this, Tuesday. Okay? So how many did I say to do from the complex section up here? 5. Don't do the first 5. Don't do the last 5. I want you to mix these up some. Mix them up because they're different types of problems. Start with those right now. First, okay. You need to write down, you need to do the 3 problems from the middle. And just,
Did you flip the ring, guys?
So FYI, if you don't know, 1 inch is equal to 2.54 centimeters. Fun fact for the day. And the other fun fact is 1 milliliter is equal to 1 centimeter cubed. Write those on your paper because you'll forget it. And you're like, I don't know this conversion.
They're directly equal.
We usually consider it for water, and they are equal. 1 cube of water is 1 milliliter of water.
Oh,
I like writing a science presentation. It just makes more sense. Yeah.
You guys know you can always check yourself on the bottom of this problem set, right? Those answers are there for little pats in the back. So why don't you guys put the same backs?
no.
Then I'll write 0 and
Can you walk me through number 4?
Let me pause this recording.